friends. We are so glad you are here. We are at the noon hour on this beautiful Friday at the St. Pete Science Festival. We are welcoming Ms. Peg Palmstein and Mr. Michael Itzkin with the USGS St. Petersburg. They're going to chat with us about how the water changes during beach storms, how relevant in Florida. Thank you so much for being here. Welcome, and go ahead, introduce yourselves, and thank you again for joining us today.
Great, thank you so much. I'm Meg Palmstein, as Harris said, and I work at the U.S. Geological Survey. And we're going to talk today a little bit about waves and water and beaches, which is very relevant here in Pinellas County, where we all live. So first of all, before I start talking about beaches, I want to talk a little bit about natural hazards that the USGS studies, the U.S. Geological Survey, where I work. And maybe you've done a unit on natural hazards in science class. Maybe some of the things you might think about are volcanoes and earthquakes, but another natural hazard that the USGS studies are coastal hazards due to storms. The kinds of storms that we're interested in are hurricanes or winter storms that might cause changes to the beach or areas near the beach. And so you can see in these pictures that I have up here, on the right-hand side, you can see a picture of a road near a beach before a storm, before a big hurricane, and then after, and you can see what happens to the road as it's washed away due to waves and other processes that I'm going to talk about now acting on that beach. So one of the important things about natural hazards and reasons why we want to forecast natural hazards are that it can cause you to change the way you have to live your day-to-day life. Natural hazards might affect where you choose to buy a house. Oh, my screen is not shared. Hold on. Here we go. Can you see my screen now? All right. All right, so on the left, the right-hand side here, you can see that picture that I was just talking about, where the road is washed away during a hurricane. And so that might affect how we live our life. And so that's one of the reasons why at the USGS, we make real-time forecasts of coastal change hazards. And so some of the things that we're thinking about is, what does the beach look like? And what does the water look like at the beach? So right now I'm going to play a little video for you of the beach. You can see this is a cartoon of a beach and a sand dune, and here's the water. And we're going to take a look at some of the things that change the water level in the ocean. One of those is tides caused by the gravitational effects of the sun and the moon. Another thing that can change the water level is surge due to the pressure and wind from a storm, and then waves caused by wind blowing over the ocean surface. One more thing that can change the water level in the ocean is actually rainwater and discharge that comes out of rivers. So those are some of the things that we're considering when we're making a forecast of coastal change hazards. Now I'd like to see if you can remember back to last fall. There was actually a tropical storm that passed offshore of Pinellas County called Tropical Storm Ada. You might remember getting the day off from school, so you had to change your day-to-day plans because of this natural hazard. And this is a picture that somebody took of the beach from a tall building at the time that Tropical Storm Ada was passing. Some of the things you might notice from this picture are waves running up on the beach. You can see that there's some sand that's come up here onto this walkway at this building during the storm. And then we can also take a look at what did it look like the day after the storm when we went out and looked and saw what the beach looked like. Some things that happened were sand and water in the parking lots and here in the walkways of this building. You can see the sand dune that's here protecting the beach eroded away, and there were lots of changes to the sand on the beach. So this is the type of event that we might want to try and forecast. So now let's take a look at the forecasts that we make of a storm like Tropical Storm Ada. So this is a forecast for Pinellas County, and you can go look at these forecasts yourself. Maybe you can find the forecast that's closest to your house. or your favorite spot to go to the beach. When you look at this forecast, you can see along the bottom of this plot different times while the storm was passing. And on the vertical side of this plot, you can see different elevations. And on this plot, we can see the elevation of the tide in the surge. That's the dashed line, just like the tide and the surge that you saw in the video I showed you a little bit ago. Another thing you can see is the solid blue line that represents the contribution of waves to the total water level. Once we know those things, we can also think about how unsure we are whether our forecast is right. And so this light blue color area represents how sure we are whether our forecast is correct. You can see that our uncertainty increases during the course of the storm. And then we compare this total water level with the height of the dune, the base of the dune, and the top of the dune. And then you can see the same kind of a plot here down below. It's just a little different now. We're looking at a slice across the beach, and there's the base of the dune and the top of the dune. And here are the two water levels that we're interested in. So now I'm going to play a video of our forecast, and you can see first the waves were low, and we were pretty sure about our forecast when we still had calm weather. And then the storm waves are going to come here starting on November 10th. They're going to get bigger, and you can see the dune changed colors when the water is touching the dune, and it might be eroding the dune or even running over the top of the dune. So those are what our forecasts look like, and anyone can go look at those on our website. One of the things that we want to do is test whether or not our forecast is right. And we also want to understand how we can make our forecasts better. And so now Michael, who I work with, is going to talk a little bit about the instrumentation that we put in the water right here off of Pinellas County to test our forecasts. Go ahead, Michael.
Thank you, Meg. So my name is Michael Litzkin. I work at the Usgs, looking at these natural hazards and how our beaches evolve over time. And so looking at some of the tools we use to make and test these forecasts. So starting way off the coast of St. Petersburg, we use wave buoys. This is a picture of one that we put out there a few months ago. And we put these way out in deep water, and it sits on the surface of the water and it measures waves as it goes by. So from this instrument, we can look at wave height, we can look at the direction the waves come from, and we can also look at the wave period, or how fast the waves are moving past our buoy. And this video here shows where that buoy is actually anchored into the bottom of the Gulf on the seafloor. You can see one of our scientists installing it. And at the bottom of this cable is a pressure sensor. And what this does is it allows us to see the changing water levels where the buoy is located. So as the water level goes up, the pressure increases on our sensor. And as the water level goes down, the pressure decreases. So we can see both the waves from the buoy and the overall water level from our pressure sensor at this location. And there it is. Okay, so moving into shallower water, we use this tool here, which has a long name called an acoustic Doppler current profiler, or ADCP. And I know that's long, but perhaps the word current might give you some idea as to what this instrument does. So this uses sound waves to measure the speed of the current passing above it from the instrument location up to the surface of the water. And you can see it installed there, some marine life living on it. Okay, so those previous two tools tell us something about how the water is moving and what the waves look like. But as those waves approach the beach, we need to know what the land looks like both below the water and then on the surface of the beach. So one of the ways we measure the slope of the land below the water is using jet skis, as you can see in the animation here. So the jet ski has GPS, so we know where we're measuring our locations at. And then it also has a sensor on it that lets us measure the depth from the jet ski to the bottom of the water. And so as the bottom steepens, the waves slow down, they get taller, and eventually, like you see when you're at the beach, they begin to break. And so where the beach goes above the water level, we measure the surface elevation with a bunch of tools, but particularly LiDAR, which is a type of laser we can mount to the bottom of an airplane, like you see in this picture. And it flies over the beach, and the GPS in the plane tells us where we're measuring, and the LiDAR sensor tells us how what the surface looks like. So we can measure the slope of the beach, we can measure how tall the dunes are, and we can get pretty good coverage from our airplane. So now those tools help us produce our forecasts, but we want to know, are we making good predictions and how can we improve them? So one way we test this is by using beach cameras. So the camera on the left is one here in Madeira Beach. The picture below it is what that camera is looking at. And on the right are two camera poles we just installed up in North Carolina near Kitty Hawk. And the picture below that is an image from one of those camera poles. And as you can see, the cameras are really high up, so they allow us to see the whole beach, and then also where the waves are breaking. So we can use these images to compare to our forecast and see how good we're doing. So if you remember that video Meg showed before, this is where that location is, here in Madeira Beach. And the blue line in the camera picture shows where the water is predicted to be from our model. The solid line being kind of where we most expect it, the sort of shaded area where it may be. And the green dot shows where we actually see the water level from the camera image. And so you can see our forecast did a really good job at predicting where the water would be here on that particular day and time. So those are some of the tools we use. And now you may be wondering, why does this matter? So making these forecasts is important for a bunch of different reasons. One of which is to be able to predict where the beach is going world, and they're important places for tourism. So we want to know, is it safe to go to these beaches? Are they going to change? Should we manage them to be wider over time? And of course, if we think about sea level rising, that's a part of the total water level. So as sea level rises, our water levels are going to increase, along with the effect of the waves and tides that we talked about. So if you have any questions, we're happy to take them. If you want to look at some of these forecasts, you can go to the link on the top of this slide here. We have locations all along the East Coast and the Gulf Coast, and locations coming soon on the West Coast. So you can see how our dunes are going to be impacted all around the country. There's also a fun story map you can look at on this middle slide with some neat pictures and videos about what we talked about today. And of course, you can visit our USGS website.
Hey, yeah, let's hear some questions. Remember, the button below the video will allow you to submit a question, and we want to hear from you. We want to hear your school, represent your school. Let's hear from you out there. I'd like to hear, Michael, I know LiDAR technology, I know, is growing quite quickly. I was really fascinated. Maybe could you tell me a little bit and tell all of us a little bit more about the LiDAR technology on the planes? That's pretty neat.
Yeah, so the LiDAR uses a laser that's emitted from the plane sensors, I think usually on the bottom of the airplane, and it bounces off the ground and returns back to the sensor, and we can use the time it takes to determine kind of what the surface elevation is, right? So the distance from the plane to the ground. And we may get numerous returns from our signal. So if it hits a tree or a house or whatever else, and we can try to parse out where the actual ground elevation is from the laser as it returns back to the plane, so that we can see kind of the surface below the trees and get a truer image of what we're looking at.
It's fantastic technology, and you guys are all cutting edge right now, helping our environment in so many different ways. What about a question we have? Tell us a little bit more about the beach cameras and how are they taken care of, and what you may have seen on those. Maybe some pretty exciting, wild pictures you've seen in live beach camera footage.
I can talk a little bit about the beach cameras. So once we put them out there, they pretty much take care of themselves. They're connected to the internet. So we send the data back to our office, and we're able to look at it. Some of the exciting things that we've seen, just in addition to the things that we are studying for scientific purposes, there's often birds flying through the image, and so we've got some cool pictures of birds flying right up close to the camera. Sometimes you can see patterns in the waves or the currents that are really beautiful and artistic, in addition to being scientifically useful.
Certainly. And what about on top of that question, what are the differences you're seeing? Maybe you said you have a camera here in Madeira Beach and then one in Kitty Hawk. Of course, we think of a beach as kind of similar, but what are the patterns that are much different?
So some of the things that are different between our beaches here and Kitty Hawk are the sand that makes up the beach. And so Kitty Hawk might be more quartz sand coming from mountainous regions, where here we might have a mixture of quartz sand and shells, and that's what makes our beaches so white. It also affects the shape of the beach, the different types of sand and the different sizes of sand. So those are some differences. And then a big difference are the size of the waves between North Carolina and here. So North Carolina, the waves are usually traveling across the Atlantic Ocean. So they've had a longer distance to grow bigger. And for the wave period, or the time it takes a wave to pass a point, is usually longer in the Atlantic. And so that can result in generating bigger currents. Here in St. Pete, we might have smaller waves on a day-to-day basis, but when we have a big storm passing offshore, we have a very wide continental shelf. So the land under the water is very shallow for a long way, and we might get a larger surge, so that there might be more water pushed up on the beach during a storm here than we would find in North Carolina. So those are some of the differences.
Thank you. Yeah, definitely different beaches all around, of course. We've got another question coming in from Razi at Academy at the Lakes. Thank you for the question. Do the scientists travel beyond the US?
Most of our work is focused in the US, but we are interested in beaches all around the world, because they can tell us different things. So sometimes we do work with other countries or other universities in other countries, and travel and learn and compare between beaches in different countries.
Certainly, that's a good question, because yeah, of course, there's beaches all around the world, really, and of course, you guys are collaborating and maybe seeing different patterns or similar patterns. That's really neat. Another question we have coming in from Delaney. How many people does it take to make these machines? Maybe let's talk about maybe the underwater ones. We saw that video, a really fascinating video. Well, tell us a little bit more about the making of those machines and how
The one video with the current meter that was kind of covered in sea life, we do need to clean that since it's sensitive to things on it. The pressure sensor, I'm not too sure about.
So every month, or every few months, we send a team of people out to take care of the instruments, and we have to go collect the data from them and bring that back to the office so that we can look at it and analyze it. And then the other part of it is we usually buy our instruments from a company, and so that there were engineers and scientists who had to figure out the techniques to make those measurements. Sometimes we figure out the techniques ourselves, and sometimes we buy an instrument that's already made by a company. And so we'll work with that company to learn more and make more measurements.
So it takes a team. I'm wondering, was the sea urchin, is the sea urchin on the video on staff or a volunteer?
That would be a volunteer.
Okay, great. Well, I again, the water videos were so fascinating and great video, really up close and personal. And it looked like not only were we just there, but very clear. Really amazing to see that. And you mentioned how it takes a team, and how many people work just with USGS in the country?
Gosh, I'm not sure about the country. In our office, we have about 100 scientists.
Wow.
And yeah, and we do all different types of things. So our group studies coastal change hazards, but we also have groups that study coral reefs. They study how the reefs are growing and changing, and how the waves and currents are affecting the coral reefs. We have people who study marsh environments. So, you know, the muddy, sandy tidal flats and marshes that we have in some areas here in Florida and other places in the US. We have people who study the bacteria in water. And we have people who study the sediments and the geology on the seafloor. So we have a really wide range of topics that we study.
And that's one of the things I love about USGS. I'm familiar with USGS and know some people that work there. And what's so fascinating, you just touched on it, is that you do anything from high up in the air to on land to below the sea level. It's just amazing. You guys cover all different formats. So all of our learners out there, think about this. Do you want to be up in the air? Do you want to be on land? Or do you want to be underwater? I mean, USGS has it all. You have all these options. And what's really fun too is you could be in the office or you could be right there on the water, like Michael was showing us right below the water there. So many options. And just right here in our beautiful city of St. Pete, over 100 people working in an office in a great location near downtown St. Pete. Just so many opportunities to really become not only do what you want to do, but be in an environment that you want to be. And that's really unique because not every organization or company has all of those type of environments. You said anything from swampland, of course, too, which is really fascinating. So I want to thank you all so much. Just very, very pleased and happy that you were able to join us here today on our St. Pete Science Festival. Thank you for doing this. We are all learners, and today we are virtual learners, but we are a community of learners, no matter if we're behind a computer screen or out under the water or in the air. Thank you, Meg. Thank you, Michael, for being here, and appreciate it. Again, if you have any questions for us going back for the next speakers too, click that button below the video, and we'd love to hear from you. Represent your school. Thanks, Meg. Thanks, Michael.
Thanks, Harris. Bye-bye.
Take care.